Hello guys, my name is Ethan Jacob C. Rosca, and today we will be talking about discontinuities of a function. So most of the time, a function is continuous, but there are some instances where a function could be discontinuous. There are three kinds of discontinuities. Okay, the first kind of discontinuity shown here is unremovable discontinuity when the function can easily be redefined as such and such that the gap in the function will be shadable. We can shade that in the graph. For so for this function, we have x squared minus 4x plus 4 all over x minus 2. So when we graphed it here, we notice that everything is okay except for when the x reaches 2. Because when you look over here, there are two values for x is equal to 2. You can notice that 0 over 0, this one would be if we substituted 2 to the original equation. But this other one, 0, will be if you substituted 2 to the redefined equation, which is x minus 2. Here we also have a table of values denoting the function x minus 2. But when we substitute 2, we finally get a value, 0. And finally, we can shade the hollow part right here. And then finally, we can make it a continuous function. Here, the discontinuity can be removed. This is known as a removable discontinuity. So the next one here is known as the jump discontinuity, number 2. You can see here, in a jump discontinuity, the graph seems to be continuous until at some point, then suddenly it will jump to another point before continuing again. This one, it cannot be removed, it cannot be redefined. An application for this in daily life would be like a road. Let's say, and a fault. Let's say you were on a road here, and here there was a strike slip fault. Suddenly, the fault moved, and then it broke the road into two parts. It left a large gap for you, and you cannot continue on the next road until you have to walk a few miles before continuing on. This is a jump discontinuity. Number 3, over here, this is an infinite discontinuity, meaning that regardless of where it is, the function's discontinuities are all infinite. For example, here, it cannot hit 0. The function here in y is equal to 1 over x. You know that it is asymptotic to the to the y-axis, meaning it cannot hit the y-axis. Meaning, because of this, it cannot hit 0. If 0 is here, you see that the limit that it doesn't exist in 0. The function is not continuous. This is called an infinite discontinuity. And in this infinite discontinuity, regardless of what you do, you cannot redefine it. It's just infinite. It goes on and on and on. Because also, remember guys, in a rational function, the denominator can never be 0 because it will make it an undefined an undefined number. We haven't reached the value of x over 0 yet. So, and there you have it. the discontin these are the discontinuities of a function. Thank you guys for watching.